last year? But now
No, I don't know. You guys probably not. Other people in the class, maybe.
It frustrated me for a long time.
Yeah, I should.
It's sort of like the brakes thing, right?
Yes.
Okay, yeah, that.
All right. So if you remember, there was, and maybe I can print this out for you. Probably not today, but there was mass. You can convert to moles. Moles. You can convert to particles. This would be on the given side. And this would be moles, mass, and particles desired. So everything we have done up to this point is we've been sticking with one substance and just converting it to a bunch of different things. For example, we got 12 grams of sulfur. How many atoms is that? How many moles is that? How many how many atomic mass units is a certain amount of atoms? How many atoms are in, 6? How many hydrogen atoms are in 6 H2O molecules? Type thing. It was always one substance. Okay? The whole stoichiometry is now taking that same concept, but now driving it into chemical reactions. Okay? I'll try to get you a sheet for this. You might actually have it from last year if you kept it. Okay? But remember, we can convert from mass to moles always using what?
Molar mass.
Molar mass. Every single time, whether it's on the desired side or on the given side. And then you can always convert from moles to particles using what? Avogadro's number. Now, the only thing that's technically a little bit different from what we've been doing is this part, which is your mole ratio. And if you remember, your mole ratio is really how we convert from one substance to another, and it tells us how do we find it? Do you remember where we look? Coefficients
I don't
from.
remember how.
Okay, so if I have H2O, I have 2 H2Os, got O2, let's start with an easy one. Okay, I know that if I have 2 moles of O2, then that's not going to produce 2 moles of H2O, is it?
No.
It's going to produce how many moles of H2O?
Half.
4. Right, isn't it double? If I have 2
yeah.
of this, I would have 4 of this.
Yeah.
Okay, so that's essentially what the mole ratio does. Is it takes and keeps our equivalent amount of each of these guys and allows us to go from one substance to another and how they relate to each other. Okay, it's not rocket science. It's not crazy stuff, but it is really useful because I can predict how much mass of this I have or will be produced if I've got a certain amount of reactants. And we're going to get into limiting reactants tomorrow. I won't be here tomorrow. You guys are going to try to do it on yourself, and then I'll probably just review it. But that doesn't mean I want you to not do anything tomorrow. Cool? Okay.
Yes, Mr. Kramer.
Thank you. All right, there we go.
Okay.
First one.
This thing had a little crack.
Now, most of these are going to be 3-steppers just because we've kind of done 2-steps and 1-step problems earlier in this chapter. Now, they weren't like going over the coefficient bridge, but you guys understand that if I start with a given mass and it's asking for desired moles, that would only be a 2-step problem and it's not a 3-step problem?
Yeah.
Or if I'm giving a mole number of a reactant and I want to know how many particles of a desired product, that's not going to be a 3-step problem, that's only going to be a 2-step problem?
Yeah.
Okay, just want to make sure we're
You
good
don't
with
count
that.
the end product.
What was that?
You don't count the end product as a step because it's just a product.
I'm not sure if you said that.
Like if you're going from moles to particles, you wouldn't count particles as a step.
do theirs between.
Yeah, how you get from one thing. Those are just units. Yep.
We can count.
Okay, so you always start with what you are what? Given, which is 96.1 grams of propane. Anyone know which one that is?
C3H8.
Okay, now I don't probably need to do this anymore myself, but you may or may not need to. Look at where we're going. Where are we going?
Mass.
Mass of.
Oxygen.
Okay, so I'm starting at mass and I'm going to mass. Now, you probably think, well, if you start at mass, you end at mass, what do you got to do? You got the right answer. Is it 96.1? No, it's a mass of something different. So we are going to cross the bridge. So mass to mass would be how many steps? What? A mass to mass is bookend molar masses. So, very important that we make sure our units work out here. First, I go to moles of given. The reason why I've got to go to moles is because I cannot transfer from one to another substance unless I'm in moles. Because masses can change. Or be different, I guess. Are you guys just doing this or? Okay. Alright. Griffin, why don't you help me out here? What should I do?
Molar mass of
Okay. Units, where do they go, and you know the numbers?
the molar mass on the bottom, grams, and then 1 mole on top.
Okay. Does anybody have that mole number or that mass number?
44.16.
44 point, what'd you say, Annie? 11?
No, it's 1.
That's what I thought.
21, yep.
Oh, you're right. I was wrong.
Okay, and it's very important. I don't do this as much as I should, and I apologize that I don't always write the substance next to it, but technically that is pretty important because I can't take grams of propane and cancel out with grams of oxygen. That won't work. Okay? If I've converted to moles, now this is where I go over the bridge and I look at the what? Coefficients, okay? So I know I gotta have my moles of propane cancel out. And I know I'm trying to figure out how many moles or oxygen, I'm trying to figure out mass of oxygen, so I've gotta get the moles of oxygen. And then I take those numbers, or I look up at the chemical equation and I figure out the ratio that I would need to convert from moles of one to the other. Moles of oxygen gas is what? Moles of propane. That cancels. Last step would be your final molar mass, but it's the molar mass of what? Did I mess something up? And what do we got? 3 sig figs, so what's your answer?
You're 49.
249. Okay, well, looking at what we have coming up, it's essentially the same problem, just solving for different things. You just change the top part of the mole ratio and then last molar mass. Yeah, I'm gonna do it. Essentially, next to you're just changing those. And I realize that may actually be easier for you. I'm probably making you do less work than you I really think you should. But I want you to realize and notice that if I have some information, if I have one piece of information, one mass of something, I can figure out the correct amount of mass of each other thing that will be either reacted or produced. What is it, 44.01? Okay, maybe it was 44 something. Get an answer for the next one? 280 what? I got 288.
Oh, you're right, round swing, you're right.
Okay. Going too fast. You with us?
Yeah, I did this one. I was still doing this box one.
Oh. Okay?
We're gonna do the next one.
Yeah, do the next one. We're doing good on time, so there's only 2 more after this. I would really like to throw one where you convert to particles, but they don't do that. Which, if I wanted to know how many particles of water vapor would be produced, actually, why don't we do that? The last problem, instead of figuring out mass of H2O, figure out how many particles of H2O there would be. Does that make sense?
The one we're doing?
On
One I already did.
the next, yeah, did you finish this one?
Yeah.
Okay, so on the next one where it's talking about water vapor, change this mass to molecules, or how many molecules. I do want it to, look a little bit different because there's a good chance in your homework you'll have to do that. It just changes the last step, which I think you guys will have no problem with, but I'd still like to make sure if there's any issues that we can deal with it. Okay. Done? So this would be what, 4? That's H2O, correct? And then instead of molar mass here, what are we using? And it was 5 point something, I think. 5.25 times 10 to the 24th. I need to write it. You guys good? Rylan, going too slow for you? All right. I'll pick up the pace then. Let's do this one. Sorry, I just don't know. I don't get enough feedback from you guys to know if you're with me, if you're ahead of me. You just don't like to talk much. So like, if you're like, I'm done, let's move on. It's okay to say, Mr. Kramer, let's go. I'm serious. Like, I'm not going to be offended by you telling me I'm going too slow. The only reason I'm going slow is I don't want to leave anybody in the dust. Okay? All right. Here we actually have to do what before we do the stoichiometry? We got to write the formula, or write the equation out. We got to balance it. Then we got to do the stoichiometry. Then we got to take the unit. It looks like it's in kilograms. We're going to have to take that and turn it to grams. Got a little bit of work to do. Why don't we do this together here then quickly? I'll just call on you. You tell me how I would do this. Rylan, help me write lithium hydroxide.
LiOH.
Say that again. Sorry.
LiOH. Sorry, 1 minus 1 plus.
All right. Good. What else? Use space vehicles to remove. So we're removing CO2. I think you guys all know what that is. This is actually kind of cool. I don't know if you understand the context of what this problem is saying, but in astronauts and people that have to go in outer space, they don't just have to bring oxygen tanks to like give them oxygen, but they also have to bring these little lithium hydroxide, they're usually like pellets. And the reason why they have to bring them is because when the people up in the space stations or whatever are breathing oxygen in, what do they breathe out?
CO2.
CO2.
The plants. And I don't have Snapchat.
Maybe they have some plans, but it's not enough. I guess I don't know. Essentially, they would all suffocate if they didn't have these lithium hydroxide pellets or whatever that would react with the CO2 because the space station would fill up with CO2 and they would what? Suffocate. Okay? So I think it's actually kind of cool. As we progress on here, Grant, what does it produce?
Li2CO3.
Nice. Li2CO3 and what?
H2O.
Say the phases on these.
Solid.
Liquid water, huh? How do I get rid of the liquid water? I wonder.
Indulge and drink it.
They probably got some system. Okay? Now I gotta balance it. Can we visually balance this or is this too difficult?
You just put 2 in front of the lithium hydroxide. There.
Okay, lithium's balanced. What do we got? 4 oxygens and 4 oxygens. We got 2 hydrogens, 2 hydrogens, 1 carbon, 1 carbon. We're good, looks like. Okay? Right? So then we got kilograms here. That's a no-no. What do we need? How many grams is that? If you don't know it's 1,000 grams, could you set up a conversion factor and do it the silly Mr. Kramer way? Then I want you guys to finish. I need to sweep the floor. How many studies of Hall do you have, Emily?
1.5,
UTA or anybody?
maybe 2.
Maybe what?
Second semester.
Jen?
Yeah.
Ah, you could, she'd probably have to do a lot. Maybe not.
She has her TXT
Why?
I was just wondering, I don't really need another TA, but
You have 1 or 2?
I had two. First time I had 2, but I have 1.5 because my second only has opposite fire. But I'm glad I need more than 1. Last couple of years I've only had 1 and it's only been opposite choir. So I've really only had half of a TA. And it's a big help. How are we coming? Any questions so far? Hey, welcome, triumphal procession. Okay. Grant, what'd you get?
918.8.
918.8. Okay, we're probably gonna go with sig figs from this, so 919. Emily, did you get that? Annie? Rylan?
I got a little lost.
Okay. What did you do?
1,000 grams of CO2.
Okay.
And then,
Well, is it CO2?
wait, carbon dioxide.
Sodium hydroxide.
That might change your answer. Right? Yeah, so you're gonna
I
have.
thought it was acid. Oh, so you're solving for carbon dioxide?
Yeah. So you had, yeah, not, right.
What mass of carbon dioxide can be absorbed? Yep. So then you would have molar mass of lithium hydroxide, mole ratio of lithium hydroxide to CO2, molar mass of CO2. Can you just flip it?
Yeah.
Do you want me to go any more into that? Or does that make sense?
What's the molar mass of lithium?
Lithium hydroxide, 23.95.
Okay. Then I can figure it out.
Good. All right, next one, and we're done. All right, if we look at this, I'm gonna let you guys do this on your own, but this is essentially a heartburn problem. Okay, there's two different antacids. It wants to know which one's better. I can just look at this and tell you which one's better. I couldn't tell you the numbers. Anybody up here could look at this and tell him which one's going to be more? Which is going to do a better job of.
Look at my knees.
Bottom one.
The mixture of two HCLs, okay.
Yep, because we're reacting with HCl, and this has the ability to react with two moles of this will react with this. This only has 1 mole, so you're essentially for every 1 gram I get of this, I get 2 parts of this. Or sorry, 1 mole, I get 2 moles of thing that's going to react with the acid. Okay, so why don't you guys do the math and just prove me right. What? Yeah, I know what you're supposed to do. So if you look at this problem, it wants to know which one's more effective per gram. So I have 1 gram of this, and I have 1 gram of this. And I want to know which one will react better or react more of the HCl. You're trying to figure out, you could stop at moles if you wanted to, or you could go all the way to mass. Does that make sense? Still not make sense? NaHCO3. I'm just going to do a 2-stepper because it's quicker, and I don't need to go all the way to 3 steps to figure out which one will be more effective per gram. Okay? So I want to figure out how much of the HCl will get reacted, because that's the goal, right, of an antacid is to react with the acid that gets produced in your stomach so you don't have heartburn anymore. We got mole of NaHCO3. What do we got? What's the ratio here? 1 to 1? then you just got molar mass you gotta plop in there, I think. What'd you say? Getting a little sick in here?
Yeah.
I don't have mole numbers because on mine I have to convert all the way to grams. But do you guys understand why I can really stop at moles and compare to see which one did a better job? And I don't have to go all the way to grams.
And the bottom is lighter too.
Well, I would base it completely on that.
Which is gonna be more for a gram.
I mean, that has a part in it, but the bigger part is the fact that it reacts with 2 times as much HCl. Yes, I'm not saying the math doesn't play a part, but so which one could you react to more moles of? Second guy. I don't know what it was, but if you think about it, the reason why I don't need to convert this all the way to mass isn't the last step going to be the same for both? You're just doing the molar mass of HCl for both, and so is it going to change it at all? No. Okay? So I don't have the actual numbers. I don't know if you guys want to check with each other, but it should be able to react more with the MgOH than with the other antacid. What do you get the numbers? 0.01 and 0.03?
Yeah.
Okay. All right. Any last questions?